Welcome back. We are still at SPARCS 2018, or SPARCS 18 on Twitter, and we are joined by Jessica Hekman, who just gave us a great first part of her talk. So we're going to do a short Q&A before the second part. And I guess the first question I had is that you've made the point that just because the way a dog behaves might seem ingrained or difficult to change, that doesn't mean it's genetic. But there's also this repeated comment, it's all in how they're raised. So how would you respond to that?
I don't think it is all in how they're raised.
Yeah.
I mean, I think people like to say that. Who is it who has the lovely Pibble, Theodore?
Trish McMillan.
Yes. And she has some lovely answers to this, right?
Yes.
About how it's not all in how they're raised. She has this lovely example of this pity type dog who was raised by dog fighters and yet is an amazing, wonderful, cuddly, slurpy, amazing creature. So no, I mean, I think, and I'll continue to talk about how, and I think in the second part I'll talk more about the interaction between genetics and environment. So genetics is important, so it's not all in how they're raised. Environment is important, but so then when you get someone like Theodore who had this rough start and presumably was even bred intentionally to be a fighting dog and yet very much turned up not like that, you have to say, well, what's going on with him? And some of it, of course, as we've talked about, is that genetics is very complicated. You don't always get what you breed for, but environment is very complicated and you don't always get what you raise for either. And so what I'm trying to do in this talk is to show that there's all this stuff that we don't really control as much as we would like to control. And so who knows with him that he just, his mom was chill or he had a really good time in the nest with his litter mates or something like that.
So when you hear to that point, people are trying to understand this, right? Humans are trying to make sense of this all. And so another way is they'll say, aha, it's 20% genetics and 80% environment. Yeah. How do you address that?
Yeah, it's interesting because we really like to think of it that way. And I had this one class where students kept saying to me, like, well, but what percent is it? Like, is it this percent or that percent? And you cannot think about it that way. So the numbers, when we do these heritability studies and we find numbers to say this trait is 20% this and 80% genetics, more often 20% genetics and 80% environment, it's across a population. And so it says that across that population, the variation in the trait that you see across the population is 20% due to genetics. But that doesn't really say anything about the one individual. And so with the individual, it's really that your genetics set you up to have a risk for something happening, and then your environment provides the trigger. And so you can be more or less sensitive to the trigger, and we can be more or less aware that the trigger actually happened, but it's this constant interaction. And again, in the second half, I'll go into that in much more detail, and I have these great little figures that show with lines on graphs, and so it'll be super clear.
Figures and graphs, oh
Yay.
my.
It's not as horrible as it sounds.
No, we're not.
No, that was genuine excitement.
Yeah, no, I know you're excited. I'm talking to the camera. I'm worried
We're
about
all
them.
excited.
They're all excited.
Yeah.
The people who are watching on Twitter are self-proclaimed, dog nerds and genetic geeks.
That's true.
And
That's true.
don't worry, we're all in this together.
Okay.
We found our people here. So we had one of the questions came through on Twitter in regard to some of the information you were saying about the in utero stuff. It was fairly specific questions asking, is there a defined quantification for the amount of cortisol necessary for the placenta to send the message to the fetus? Or does it vary from individual to individual?
We don't know. That's definitely something we don't know. I would love to know that. I would love to be able to do a study where I look at how many receptors there are for cortisol in the placenta, and then look at how the puppies grow up. And the problem is getting in there to look at the placenta without hurting the puppies. And I haven't figured out how to do that one yet. I'm still working on that one. No, we really don't know. We really don't know, and the humans don't know either. It's a really tough one.
On that note, I guess what I was going to say is, we're finally starting to look at maternal effects in dogs, which is really exciting. And I guess one of the things I was going to ask is, in regards to that new research, is there much that we can infer from studies that have been done in humans? And that could relate to the in utero stuff too, because always people are more studied than dogs. There's much more funding available for research into people, and being that a lot of our research is done with the intention of understanding ourselves and medical benefits and health risks and all those sort of things, generally there's more done with people. So how much can we infer or take as being a possible analogue, and how much has actually been done in contrasting and comparing? Dogs
Yeah,
to
I think
dogs?
about 53.8%.
Yeah, nice. Perfect. Thank you.
Okay, I'm going to
Done.
write it down.
Done.
No, and given the
Yeah.
I guess given the differences too in our reproductive systems and
Yeah,
things like that, because
no,
a mammal is not a
exactly.
mammal is not a mammal. So.
Right, exactly. And I'm often frustrated when I'm teaching people about dogs, and I love dogs, and I want to just talk about dogs, and not humans and rats. But all of this interesting stuff was done in humans and rats for obvious reasons. And so there are some things that, hopefully most of you are aware of the term highly conserved, right? So there's a lot of parts of the mammalian system that's highly conserved, meaning that it's just really the same across most mammals. And then there's some parts that differ, and sometimes it's surprising to us what parts differ. And so I certainly assumed before veterinary school that a placenta was a placenta was a placenta. Like, I wouldn't have thought that there would be different placental types in different mammals. Like, we're all similar, but that's one thing that differs. And so I think for a lot of this stuff, it's nice when you see that it's the same between the rats and the humans. So that gives you a nice, fairly wide evolutionary gap to say, probably this is the same in dogs, but you can't really assume. And so it is true also that I say these things, then I say, oh yeah, we're almost positive this happens in dogs. But yeah, we don't really know. And so I'm really glad that these studies are starting to expand into dogs.
And
to
what,
see
I
if
guess
it's
what
true.
are some of the things that are coming out? What's some of the newer?
Well,
areas
the
of-
maternal effect studies are the big ones. I would love to start seeing people being able to do these studies where we're actually looking at the hippocampus and seeing what the difference is in the hippocampus. And the problem with that is getting a hold of dog brains ethically. And so people can do these studies in humans because there's this amazing system set up where a human dies and donates their organs, and they can come and say this is an appropriate one for studying, and they'll take the hippocampus. And there's this great infrastructure for doing that. And then there's rats where we just do it, and dogs fall into the middle. And so we're in Carlson Lab, we're working to try to find ways of getting hold of donated dog brains when dogs are euthanized for other reasons by their owners. And that is obviously a very slow, delicate process, which we are early on with. We do have a few brains, not enough to do anything with yet, but we're starting a sort of proof of concept at this point. So I'm really hoping that we'll get there at some point, but it's tough.
Yeah, absolutely.
Yeah.
Absolutely.
So also looking to the future, from Twitter, we had a question, are there recent advances in dog epigenetics or elsewhere?
Yeah, so
epigenetics?
people don't tend to study epigenetics in dogs so much, and so I don't want to be too focused on Carlson Lab. It's just that I know what we're doing and not
Great.
necessarily what other labs are doing. And so there's a very interesting project in our lab right now looking at, so it's, I guess I could call it epigenetics because it's looking at the shape of the chromosomes, and which is really what epigenetics is these bookmarks saying, go look here to use these genes, and that's exactly what this is looking at. And I am going to be talking about that in the next part, so I will make sure to point out to you when I get there.
Excellent, excellent.
I'm just looking to see if anything new has come through.
Very nice.
Last chance.
Here's a good one that you might like to weigh in on. So someone, ironically named Scott, has asked, is Scott and Fuller a bit outdated, especially considering their facilities and breed choices?
Oh gosh. I'd have to go back and reread it.
The whole book.
So they right the whole book. So the thing is, I mean, the way in which they're outdated is that they did things that we're not willing to do today. And so they got some really strong answers that we can't get today because they were willing to do things like really determine what the socialization period of puppies is by taking puppies and not socializing them to humans at all, and then showing that then after that socialization period closes around 12 or 16 weeks that they just will never habituate to humans. And we don't do stuff like that anymore. So they still have a lot of very interesting information that it's hard for us to go back and study again because we're not willing to do those same studies. I'm trying to think if there's anything in there particular that I know of that we have found to be untrue, and I think I would have to go back and reread it. But my general feeling is it's still a pretty solid thing to read, and my evidence for that is that other speakers have commented on it.
Oh, perfect.
And they're all experts. So
It's interesting though. It's something that we were actually informally talking about over lunch the other day. Is that quite often, we tend to not dismiss or disregard but we tend to favour more recent information. And sometimes there can be really great stuff, valid information that may be more than 10 or 15 or 20 or 30 years old. And just because it was discovered, way back in 1966, doesn't mean that it's not still valid and relevant and important to what we're discovering today.
Yeah, for sure.
And that in some ways, because we're dismissing some things because they're older or not paying them full attention, we can get a little bit cyclical in our research because we have to rediscover that thing that was known back then. I guess just what's your take on?
I think it's very good to go look at the past and see and to draw ideas from there. But it's also important to not just trust it and to retest it.
Absolutely, the changes we have in testing equipment and technology.
Right.
Yeah.
So when I was in veterinary school and I had started feeding my dogs raw, I didn't feed them any carbohydrates at all. And I said, but there's this study back, I was like in the 50s, that showed that dogs didn't make amylase, which is what you need to digest carbohydrates. And I was like, well, so it's just a filler. They're not even digesting it. And it was an older study, but it hadn't been replicated, and I figured it hadn't been replicated because everyone just knew it to be true. And then this study by Axelson came out. Many people in the audience will remember what year that was. I want to say it was like 2013, 2012, something like that, around then, and a genomic study, and they found that in fact, so dogs do have the gene for making amylase, and in fact, one of the big differences between dogs and wolves is that dogs have more copies of that gene, so they make more amylase. And so I think what was happening was that in the 50s, they looked in the saliva and they didn't see it there, but maybe it's just expressed in the, farther down the GI system. I was like, okay, brown rice for you guys. So
New information.
yeah.
So I guess since you've come into this field and obviously you've moved through many areas of this field, what has surprised you the most? Or, as you're moving along with possibly even your own dogs and their changes based on their early development, or research you've picked up along the way?
So many things have surprised me. I think what surprised me the most is how much I had to learn just from my own dogs. So I adopted Jenny. I was looking for a second dog anyways. I was offered this dog who was very shy, and I said, yes, that will be such a great learning opportunity for me. And I didn't realize what a great learning opportunity she would be. I didn't understand the importance of the off switch of you get scared and then you're able to stop being scared. And that has changed for her so much over the years I've had her. It used to be that I'd drop something in the kitchen, that was it. I didn't see her for an hour, right? And now I drop something in the kitchen and she's like, oh, well, okay, I'm sure there's still food, right? And so then, so I had two dogs, and I lost my golden retriever at a ripe old age. He was a lovely dog, and I was like, okay, well, I'm going to get a puppy because I'm really interested in socialization, and so I'm going to get this puppy, and I'm going to go through that whole process and see what it's like for a puppy to grow up. And I was like, but I know it. What am I actually going to learn? I have a PhD in this stuff. Mia thinks this is hilarious.
Yeah, live it.
Yeah, I learned so much. And it was amazing, too, how I was always getting in touch with my dog trainer friends and being like, oh my God, is this normal? How long will this go on? It's awful.
I was like, don't worry, it's going to be 6 months, you'll
Just
be
another
fine.
year, just another year. Right, and then when he started to settle down, a friend of mine got a puppy, and she was like, how long is this going to go on? And I was like, by the time he's 10 months, it'll be much better. And she was like, what? He is, by the way, a lovely dog.
That's very nice. Well, yeah, so there's a lot of value in personal experience and revamping it with what you're knowing and how it informs your research. Yeah. So I think that we are going to wrap up this Q&A and let you get back to your stuff in the second part of your talk. So thank you so much for speaking with us, and we'll see you all back here for Dr. Jessica Hekman's second part in 5 minutes about.